All right. Hello, lovely people. Today we are going to look at probability. From the foundational level, we are going to look at set theory and then extend it by looking at probability today. Let's go through this question. We use it to explain a lot of other things that are attached to probability and set theory. Now, it gave us this question for the given number 1 to 12. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Determine the number of odd numbers here, the number of even numbers, the number of prime numbers, and the number of multiples of 10. So this will take us into set theory. So what do we do here? First of all, let's arrange these numbers. The sample space is actually this. So we have the sample space 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, these numbers are not actually the values, but they are treated as elements of that set. So the set that we are dealing with is the numbers from 1 to 12, and these are the elements. Now let's look at the odd numbers there. The sample space for the odd numbers are numbers that cannot be divided by 2 without a remainder. So we are looking at 1, 3, 5, 7, 9, and 11. These are the odd numbers. Then we are looking, if we look at the set of even numbers, we have 2, 4, 6, 8, 10, and 12. Even numbers that can be divided by 2. Now let's look at prime numbers. Prime numbers, the set of prime numbers here. Now, prime numbers are numbers that are only divisible by themselves and 1. So we have 2, we have 3, we have 5, we have 7. 9 is not a prime number, we have 11. So these are the sets of prime numbers. Remember, a set is made up of elements. Remember, those elements cannot repeat themselves. So this is the set of odd numbers, set of even numbers, set of prime numbers, drawn from the original sample space given to us, which is from 1 to 12. Now let's go. Here, they're asking us for the n odd. So if we have the number of odd numbers here, the sample space, we have 12 numbers. The number of odd numbers here is actually 6. The number of even is actually number of elements in a set of even numbers is also 6. And the number of elements in the set of prime numbers given is 1, 2, 3, 4, and 5. Now, they are also asking us for the number of elements in the multiples of 13. Now we check here, do we have any multiples of 13? So that will guide us. So number of multiples of 13 in this case will be what we call 0. If we want to represent a set of multiples of 13, the set we say it is null. Please remember it is null. If it is not applicable, in that we say that the set of multiples of 13 for this data distribution is null. So when we talk about null set, it means something that has no part in the given set. Now let's go forward and answer the following questions. Based on this, they're asking us to determine the probability of odd numbers, even numbers, and also the probability of the prime numbers. Now let's look at this. The general formula for probability, the foundation says that the probability of any event occurring is actually the number of favorable outcomes over total number of outcomes. So that's the probability of any event occurring. So if I'm thinking of that today is going to be sunny, snowy, or rainy, I have 3 possible outcomes. So my total number of outcomes is actually 3 in that case. If it rains, then favorable outcome is 1 out of the 3. If it rains and snows, favorable outcome is 2 out of 3. So this is one formula that you cannot play with because it's the foundation of everything we do under probability. Now going forward, let's get what they ask for us. So the probability of odd, please, notation is very important here. Notation is very important here. Number of odd is 6. They didn't tell us which odd number they are referring to. So all of them, there's a possibility of all of them coming into effect. So probability of odd is 6 out of the total number of outcomes. So here we have simplified. Please, it is a good practice to leave your probability answers as a fraction so that you don't lose the original value. Now let's go. Probability of even. In this case, is still also 6 items out of 12, which is 1 over 2. And then the probability of prime numbers is actually 5 over 12. We leave it that way. Please, under probability, notations are very important. You can't just write 6 over 12. You have to tell us what 6 over 12 represents. So notation is also very important. Tell us probability of what you are referring to, and then before you give your answer. So this is the answer to question B here. Let's look at the last question and we use it to answer other multiple questions. I'll give multiple explanation of what we want to go through. Now, it says represent this on a Venn diagram and also discuss the Venn diagram. Now let's look at this. The Venn diagram must be a box which includes all the events and what they represent for any given distribution of data. Now, if I have this, I have odd. Now, one thing you must always do is check the data given before you draw a Venn diagram. In the process, the first things you must represent must be the intersections where they have things in common. That must be the first. Remember, odd we have 1, 3, 5, 7, 9, 11. Even we have 2, 4, 6, 8, 10, 12. And prime we have 2, 3, 5, 7, and 11. So this is what we want to represent. So first thing, between odd and even, you check to see if they have anything in common. Odd and even don't have anything in common, so they can be on their own. Now we also check prime and even or odd if they have anything in common. So let's see, prime and even have 2 in common. Prime and odd have 3 in common. So it means there will be a form of intersection. So this is our event even, and this is our event prime. Now represent the intersections first. Whatever that is left, you now fill in. So let's go prime and even, they have 2. Prime and odd, they have 3, 5, 7, and 11. Now let's check what is left in prime. We have 2, 3, 5, 7, and 11. Everything has been taken care of. So prime, we have satisfied. Let's go to odd and fill up whatever that is left. We have 3, 5, 7, 11. 3, 5, 7, 11. So we have 1 and 9 to fill. And then into even, we have 4, 6, 8, 10, and 12. So this is the Venn diagram representing this given information here. Now let's go through the process of interpretation. We have multiples of 13, there's nothing here, so it's not, this is not part of the process. If we have other numbers outside that were not part of this, we'll put them in the empty space that completes the full set of events given. Now, let's explain what this means. using probability terms. Now, odd and even, they have nothing in common. If two events have nothing in common, we say that they are mutually exclusive. Mutually exclusive means they have nothing in common. And representing it in probability terms, we can say probability of odd intersects probability of even will always be equal to 0. It means they have nothing. This is intersect. They have nothing in common. We can also say that they are exhaustive. They are exhaustive in this case. Exhaustive means if you add what both of them have, all the terms in the given set have been taken care of. Because this might have 6 of them, this might have 6 of them, so they are exhaustive. It means that probability of odd plus probability of even will give us equals to 1. 100% of 1 is exhaustive. So they are also exhaustive. We can also say that they are complements of each other. They are complements of each other. So I can say that probability of odd is equals to probability of even complements. That means what this one doesn't have, this one has. Complement, when we talk about complement, we mean, if I say that you complement me, it means what I don't have, you bring. And that makes us to become whole. So this two explanation goes for odd and even. They can be mutually exclusive. They can also be exhaustive in this case, and they complement each other. They complement each other. Please understand this. And then we can look at even and prime and odd and prime. So in this case, I can say that even and prime are inclusive events. Why are they inclusive? Whenever they have something in common, we can say that they are inclusive events. So inclusive events, so probability of prime intersects probability of odd. If it's not equals to 0, they have a value. It means that they are inclusive. They have something in common. Likewise, probability of prime intersects even. They are not also equals to 0. They have 2 in common. So we say that when the 2 events have something in common, we say that they are inclusive events. So this is the foundation of what we do under set theory and probability. As time goes on, we'll also answer more questions and break it up further. Remember, you can create your sample space. You can create this set of events for any given information. You can break it down. You can sketch it on a Venn diagram, and you can use a Venn diagram to illustrate further. It goes on and on. Remember, the 2 foundational probability equations that you must remember is the first one given, and also the probability of A or B will give us probability of A plus probability of B minus probability of A intersects B, where A and B are the given events for the distribution. So go through this. If you have any questions, please don't forget to pop. Remember, this is laying the foundation. We'll bring more questions to give further clarification. Keep on watching, keep on sharing, and don't forget to subscribe. I'll see you.